Good afternoon, Namaste. A very warm welcome to all participants joining us for session 5 of TTDD 2025 titled Management and Service Delivery Architectures. I am Chandrakanta Rathore, coordinator for this session. Before we begin, here are a few hygiene announcements. All attendees will be kept on mute throughout the session by default. Kindly post your questions in the Q&A tab of the conference tool. This will be taken up during the Q&A section. Questions in the chat box will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing any bandwidth problems. Attendees may like to visit the exhibit booth of TSTSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. The conference sessions are being recorded and will be posted to the TTTD website in the next few days. Now, I would like to introduce our session convener, Mr. Vijay Madan. Mr. Madan is currently associated with TSTSI as advisor and mentor with special focus on standardization in service and solutions relating to evolving technologies and applications, vertical sectors use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems. Also with JWG's focus connected with FunM2M, 3GPP and IoT. Now it is my pleasure to introduce the co-chair of this session, Mr. Nirant Thamag. Mr. Nirant is the head of the architecture and automation research and standards team at Nokia Bangalore. He is a senior expert in the domain of telecom and information networks research and industry standard with over 20 years of experience in pre-research and standardization activities. His research area includes 5G advanced and 6G vertical industry applications and platforms for mission critical communications, edge computing, API and enabler frameworks, and verticals like P2X, UAV, smart factories. He is an active contributor to global and regional standards body forums and is currently serving as vice chair of TSTSI SCSS group. Welcome, Mr. Nirant. Now, Dr. Paventhan Armugam. Dr. Paventhan is Senior Director R&D Scientist G with ARNet. At ARNet, he has handled R&D projects in various domains, including the ARNet Internet of Things, EU-funded MyFire Future Internet, Educational Cloud, Visible Light Communications, Tactile Internet, QKD Network and Security. His current research interests focus on protocol and standards for IoT, cloud computing, quantum communications, and software-defined networkings. Welcome, Dr. Paventhan. With that, I now invite Mr. Nirant Thamag to take the session forward and introduce keynote speaker and handle the keynote segments. Sir, over to you now.
Thank you, Chandrakanta. Thank you for the kind introductions. Good morning, good afternoon, everyone. So on behalf of the TSDSI Organizing Committee, it is my great pleasure to welcome you to this important technical deep dive session on management and service delivery architecture. It's a critical pillar in the design and realization of the next generation 6G network, as we all know it. So as we enter into this journey of 6G, which is almost beginning to take shape, so we are not just envisioning faster and more intelligent networks, but we are architecting the system that will manage and deliver services in ways that are autonomous, context-aware, ultra-reliable, and seamlessly scalable. Right? That is the vision. This session basically brings together leading voices and leaders from academia, industry, and technology ecosystem partners to explore the architectural foundation that will enable this transformation. So our focus today is broad, but yet it is deeply interconnected. So we'll begin with a series of 4 keynotes that dive into some of the most promising and disruptive areas shaping the future of 6G. We have a special session on the role of data, because if 6G is the nervous system of future digital infrastructure, then data is its lifeblood. So this special session and the conclusion of the session will be presided by our co-chair Paventhanji. So we'll start with the keynotes with interoperable data spaces by IUDX, which is essential for breaking down silos and enabling secure, shared, and real-time access to data across networks and verticals. Then we'll hear a critical operator's perspective by Geo on the expectations and practical challenges of management and orchestration in 6G environments. Further, we'll explore intelligent exposure and cognitive agentic automation by Nokia, with focus on key enablers for unlocking the true potential of 6G services through real-time adaptability and programmable interfaces. Further, we'll deep dive into agentic digital twin-based orchestration by Tata Elxsi, a rapidly emerging paradigm that integrates AI, simulation, and automation to provide real-time digital mirror of the network and its services. So in the session for the role of data, we'll explore secure interoperable data management platforms by Fiware.org, which are essential for trust, governance, and sovereignty in distributed environments. Then we will delve into the role of data and digital twins by CDPG IISc, a powerful tool for simulation, prediction, and closed loop optimization in complex adaptive system. And finally, the evolution of data architectures by IISc, purpose-built for 6G, capable of supporting real-time intelligence, ubiquitous connectivity, and dynamic policy enforcement. So across these sessions, as you've seen, the design is such that we will examine the convergence of AI-native orchestration, intent-based management, capability exposure frameworks, and enabler technology, all converging to shape a more transparent, trusted, and resilient 6G ecosystem. So our goal today is not only to explore these technologies, but also to surface the foundational principles, the research priorities, and the standardization opportunities and challenges that will shape the path forward. So thank you again for joining us. I look forward to a day of very insightful discussions and collaborative vision building. So as Chandrakanta mentioned, to make this session efficient, I will request that all queries which require the attention of speakers be posted on the Q&A widget. And I request the speakers to provide their expert views to the queries from the participants post their talk. So with that, I would like to begin with the first keynote. So Chandrakanta, if you can bring up the introduction to the first keynote. Our first keynote speaker is Dr. Inder Gopal. He's the CEO of IUDX, and also he's affiliated with IISc. He's a research professor at IISc. He's the chairman of the Center for Data for Public Good, which is called a CDPG. Right? He was previously vice president of software at Ericsson, where he was instrumental in launching their edge computing efforts. Before that, he was the vice president of networking at IBM, where he had the responsibility of all IBM's hardware and software networking products. He has also served as chief architect of AT&T and chief technology officer of Prodigy. So welcome, Dr. Inder Gopal, and I request you to please take the floor for delivering your keynote on interoperable data spaces in the context of 6G. Yes, sir.
Okay. The title, as was just said, is interoperable data spaces in the context of 6G. Much of what I'm going to talk about actually is kind of independent of 6G, but 6G will make it better, right? I think that typically is the expectation and hope. I mean, having more bandwidth, having low latency, having some of the different characteristics that 6G provides, will, I think, speed things up, will make it easier to get access to data. So the theme of 6G goes through the presentation, but there's nothing unique about 6G specifically in what I will say. So let's move on to the next slide, please. Okay, so just very quickly, Center for Data for Public Good. I mean, all of you must have heard about Indian Institute of Science, so I won't spend any time on that. Traditionally, Indian Institute of Science is focused on fundamental research and is very well known for those kinds of activities. But recently, there have been some translational programs that have grown up within Indian Institute of Science, which are focused on not traditional academic research, but research where new concepts and ideas are being brought to benefit citizens, right? So the idea is take the technology out of the lab and bring it into actual real life. And not in all cases is this possible, but in some cases it is. And particularly in the use of data, we felt it's very important not just to do theoretical research or paper research, but to actually, or even prototypes, to actually build real systems. So the focus of what we do is building real systems for data sharing, working with a lot of government agencies at the state level, at the central government level, and even internationally. And we have a large team, a reasonably large team, I wouldn't say large team, of people who were both professional developers as well as some researchers in areas like AI and data privacy and confidential compute. So it's a mixture of research and development. So if I go to the next slide. So what is the data space? The title has the term data space in it. And this is a term that, I think sometimes has different meanings. There's obviously, it's a term that's in vogue in Europe. And my colleague Chandra, who's going to be talking later, has been working a lot on this. But the concept, at least as I understand it, is really a data ecosystem, right? Around a particular domain or a particular area of interest, right? So the data ecosystem will have many different things. It will obviously have the data. This data could be both public data or private data, right? So the key aspect is the data is distributed. It comes from many different places, right? It is not a single central database that we are talking about. If that were the case, you would not need a data space, right? You would have a database, not a data space, or a data lake or something like that. So this is kind of a very distributed, federated environment, right? Data comes from many different forms of data, and at the core of the system, right, at the heart of this is something called a data exchange, right? So this data exchange basically allows the sharing of data, and I'll talk a little bit more about that. So let's park that for a second. But around that data exchange is many different things that need to come together to make a full data space, right? So you need to have, for example, a data policy. You need to have data economics. You need to have a trust model, right, between different sources of data. These are all extremely important things, and some of them are technical, some of them are non-technical, policy related. You need to have things like training, use case templates, and then most importantly, you need to have an application ecosystem, right? So you need to have application developers who are using the data to create applications and services. And our view of a data space is that this is an open environment where any third party, hopefully a startup, maybe large companies, maybe a city government, maybe a state government, can build an application and build it very quickly, very easily, without a lot of the fuss that is required if you are building a data-driven application in India today. So let me go to the next slide, please. Okay, so beyond, so I talked about a single domain of a data space, right? In the previous slide, say around transportation, you may have data that's related to buses, to metro, to roads, transit, all kinds of things that will form a transportation data space. You may have multiple data spaces, right? So data spaces can be of different domains. So you may have a data space around transportation, healthcare, agriculture, environmental, logistics. All these things can be independent, managed independently, operate independently, and as long as you have common standards, common ways of exchanging data, they can also be thought as a part of a larger ecosystem of interconnected data spaces. And if you look at a lot of the work, for example, that we are doing already with state governments, some of you may have seen an announcement by Telangana State 2 or 3 weeks ago, where they announced a Telangana data exchange. What that really is a virtual exchange of exchanges, right? So what it is agricultural exchange, healthcare exchange, lots of different data. Each one, with independent data management, data provenance, and what Telangana has done is put it all together to create kind of a virtualized view of a single data space or a data exchange. So there are ways of interconnecting and bringing together disparate data spaces, while at the same time allowing for independent governance and independent management. Next slide, please. So let's talk a little bit about the problem actually that a data exchange specifically, which is the core of the data space, will solve. Right. I remember at the heart of the data space was a data exchange. Right. So what does the data exchange do? So typically, think of somebody who wants to build an application. Right. So let's say it's a startup. They want to build an AI ML application or some other data-driven application, or they want to train an AI ML model. So these are all different things which require huge amounts of data. Right? The data is available, right? So you may have public data, private data, personal, non-personal, video data, huge volumes of data, IoT streaming, demographic data. This is all stuff that's out there. In some cases, that is publicly available. Some cases, that is available through firewalls or through paywalls, or through other subscription mechanisms. But the data is there. The problem is that getting access to this data is very hard. Right? If you talk to any startup today and you say, what is the biggest stumbling block in your delivering a solution, they will say access to data if they're a data-driven startup. We know the data is there, but it is being held by this agency or this organization or this ministry. And to get access to it, even though the data sometimes is intended for public use, to get access to the data in a usable form, in a reliable form, is extremely difficult. Right? It takes months or years of frustration sometimes, in order to do this. And so what the idea really of a data exchange is to put a layer of software between the application and the data. Right? Typically, the software is open source. It'll sit in the cloud. It is a middleware that provides a unified way. Okay, I'm sorry. There's a lot of background noise. So I don't know, where it's coming from, but it's a unified way to obtain all pertinent data. And that is really what we are delivering as part of the data exchange. So if I go to the next slide, this shows a little bit more about the details of the data exchange, right? And this is something that we have built and we have deployed in many different places. It is based upon India Urban Data Exchange, and as you will see, it's deployed in something like 52 cities. This was sponsored, originally the program was sponsored by Ministry of Housing and Urban Affairs. Now, what we have done is we have taken the core of India Urban Data Exchange, and we've created the new IUDX, which is Intelligent Universal Data Exchange. So we have taken what started as an urban project focused on the urban sector and made it into something that is universal. Right? So, for example, here what I'm showing is the agricultural data exchange that we built for state of Telangana, and what this shows is at the bottom you see different types of data, as I showed you before. In this case, the data may be soil health, pest advisory, blah, blah, blah. Some of it is relatively static data. Some of it might be actually, very, very much more dynamic data from IoT sensors. This will require real-time communication with 5G or 6G connectivity. And some of it might be things like geospatial data, right? Which is very important for agriculture. It might be things like satellite maps. It might be even videos or other kinds of information. This will require huge amounts of bandwidth, right? And particularly geospatial data is extremely bandwidth intensive, and to move geospatial data will require high-speed connectivity, which will stress any kind of mobile network. So that's the data plane. On top, you have applications. These are sort of typical applications that we have in the agricultural sector. Smart credits for farmers, pest and soil advisories for farmers, targeted individual farmers, market advisory. These are all some of the applications that we have built and that are operating. What's in the middle is really the data exchange and the core of the systems that we have created, right? So there are kind of three different, there's two different aspects. There's what they call control plane and a data plane. The control plane consists of a catalog which basically keeps track of all the data that's available in this ecosystem, right? And metadata. So it's not just the data; it's also the standardized metadata, right? It keeps track of it keeps the metadata and it keeps track of what data is available. And then there's an authorization service which provides consent. A lot of this data is personal. For example, farmers in this case have information about their land holdings, about maybe even their personal identifying information. These are all things that are shared. Say if a farmer wants to get credit, these are all important information that will be required. You will need an authorization, a consent mechanism, which is compliant with the DPDP Act. And these are all things that are part of the system, together with a very sophisticated set of access policies that can be enforced on the data. So that's the control plane, right? And that's basically controls the flow of data. And then there's a set of things that actually manipulate the data itself. So there's something called a resource server, which standardizes the data to standard format, make sure that the data from different sources, different provenance looks alike. It moves the data securely from source to destination. You could have completely an encrypted flow where the data is never seen in the clear. You could also have things like, in addition, we have a set of analytical tools. We have a whole trust and privacy framework that ensures that the data is maintained in a private fashion. If it is required to be private, that there's appropriate privacy filters, anonymization filters, and that if necessary, the data is tamper-proof. And that third parties, even the cloud operator that is hosting this data exchange, may not have access to the data itself, right? So these are some of the functions that are part of the data exchange. And as I said, it is entirely cloud-based. It is totally open source, and it is digital public infrastructure. And our strong belief is that all DPI needs to be open source, right? It needs to be something that is available, transparent, that it is not under the control of any particular company, or it has proprietary, technology that prevents it from being broadly disseminated without licensing and so forth. So open source is a key aspect, and in addition, even though we refer to it as a data exchange, there's really no data that is particularly stored in here, or at least minimal data that's actually stored in that middleware. Most of the data is transient, right? So the data comes in and the data goes out, right? It doesn't. It mostly remains within the systems that are providing the data providers. So this is sort of some of the system architecture issues. Let me flip to the next slide. So I want to talk a little bit, more about data, and maybe give you a taxonomy, right? Which may be of interest, which really talks about the role of, the role that middleware or the data space needs to play, right, in managing data. So data typically consists of open data, right? Which is things like, when you go to data.gov, or you go to some other open data portal from any government agency or anyone else, you will get things like government statistics. You might get information about public records and so forth. These obviously require standardization of APIs, maybe some metadata standardization, and very often these are viewed through a data portal, right? Through through essentially a website, right? Then on top of that, you have at the next level of hierarchy, you may have high value data, right? So this is data that may be things like transit data, traffic data. It may be high res remote sensing data. So things which have some value that are of that the provider of the data may want to monetize or may want to restrict. You may not want everybody to get access to the data. So here you would need technology like authorization, policy-based control, and this is where the data exchange and data spaces plays a role, right? And this is something that is, you know, a lot of instances of deployment here. And then on top of that, you know, in order to really make data ubiquitous and usable in some, you know, in a variety of different applications, you have to also deal with personal and sensitive data. So this may include things like health data, right? Financial data, right? You know, you may want to train a model with health data that is appropriately anonymized in order to be able to you know, do some inferencing in terms of you know, say the progression of diseases or something like that, right? So these are things that require very strong privacy enhancing technologies. So these include things like differential privacy and k-anonymization, which anonymize the data, but may also include things which allow computation on data without divulging the data, right? So this would include trusted on execution environments, hardware-based or software-based, say things like technologies like secure multi-party compute, homomorphic encryption. These are all technologies that allow you to share data, but not necessarily to do a shared computation on data, but not without divulging the data itself. So this notion of confidential compute, privacy preserving technology, these are all extremely important in order to extend the scope of a data space or the scope of a data exchange to include, you know, personal and sensitive data. So if I go to the next slide, and I'm going to try to wrap up pretty soon. I think I'm running out of time. Standards are really important. I have here an example of another exchange that we have created, the Forestry Exchange. This uses things like OGC standards for geospatial. We are working very closely with, in fact, FiWare to contribute to ETSI standards and adopt NGSI LD. JSON LD, OpenID, TM Forum. We're also, in fact, contributing to TM Forum to create open models. And then we're working very much with BIS to create internal Indian standards, right? To standardize the APIs, standardize the data models. These are all things that are going on. If I go to the next slide. This gives you an idea of the kinds of things that can be done with data exchanges, right? So we have applied data exchanges in many different sectors. Urban data exchange is 52 different cities, mostly IoT streaming data. So a lot of this actually does require 6G or 5G, certainly 5G, maybe 6G connectivity, you know, because there's a real-time aspect. So for example, every bus in Bangalore is got a chat tracker on it, a geo tracker, and that is, you know, every several seconds, that tracker is sending its location information back, right? And that is real time information, right? And so that is extremely critical that be delivered with low latency, and you know, otherwise the value information simply disappears. Right. Similarly, we also have within Bangalore City all the information about all the traffic cameras, right? That the traffic police have installed in various parts of Bangalore City are connected into the system. If we wanted to get access to some of those feeds, that would also require extremely high bandwidth, 5G or 6G. So these are some of the examples with IEDX. There's also this edX project with the state of Telangana. We have done a lot of work on public benefits, which can use data extensively. Privacy issues that I talked about are critical. Geospatial data. So all the geospatial data that's collected by Survey of India and by many of its affiliated agencies coming through something called the Geospatial Data Interface, right? GDI system, which is something that we have built using the same technology concepts that I talked about. And this is critically remote sensing and large geospatial data sets need high bandwidth critically. And some of these other things I'm not going to talk about, but there are many, many more, right, than what I put here. Let me go on to the next slide. And I think I'm not going to talk about this. I don't have time, but
Professor
if you're
Inder,
interested,
can
we
wrap
can,
up in 1 minute, that will be great.
yeah, I was planning to do that. Let's go on. Next slide. Next slide. I think I can. Let's go next slide, please. Yeah. I think we talked about Bangalore transport. There's lots of different applications. I don't want to spend a lot of time. I want to give you the sense that look, there's a lot of ways in which data can be used. Some of it is, a lot of it really will stress the communication network. And also another aspect of 6G is that data comes from the communication network, right? So one of the things we're trying to do is get data I wouldn't tell you where, but I mean from certain sources where the mobile operator shares location data with us, and this is also extremely important data that we need to make available. So 6G and 5G systems can be sources of data, not just conduits of data. Let me stop there. I think I have another slide or two, but I think you've got the idea, hopefully. So I'm
Thanks a lot, Professor Inder.
Yeah.
So, no, thanks a lot. I think this is a very good start, where you, in fact, from the utility of the data, right, and how a distributed federated environment is very important, and you brought in a lot of views with respect to government's initiatives in data spaces, and how IUDX evolved from just an urban data exchange to an intelligent universal data exchange, and its transformation journey and its usage in live examples like Bangalore traffic and Varanasi. I know you given more time, I think that would have been very exciting to learn as well. But these slides will be available to the audience, so they will be. And as you also pointed out, IUDX also is getting mobile network data feed in some way, so which is also a good understanding of how networks, which 4G, 5G, and 6G networks, which will shape up more data into, let's say, increasing the utility of data for public good, is going to shape up. So thanks for your excellent insights on this particular space. So Nick, there are some questions, Professor Inder, that has been posted. Feel free to please answer them on the Q&A widget.
You want me to do that now?
Keynote speaker.
Sorry, the end. Okay.
Yeah, you can just you can just answer them on the in the chat in an offline mode.
Okay, all right. Thanks.
It is the written. You can just write the answers there. Yeah.
Got it.
Our next keynote is from. Thank you. Our next keynote is from Reliance Jio. We have Mahesh Nayaka Mysurannaya, who is going to present his keynote on expectations of management and orchestrations in 6G and operators' perspective. So Mahesh is working as an AVP in the Global Standards Organization of Reliance Jio. He has 27 plus years of experience in telecom, wireless, and mobile technology, including GSM, WCDMA, satellite, and everything under the wireless domain. And of course, now in 5G and 6G. He is the chair of Study Group Services and Solutions in TSDSI since 4 years. He is the delegate in 3GPP for SA1 and SA2, and he has over 25 filed patents to his credit. So I welcome Mahesh to please take the floor to deliver his keynote.
Thank you, Nirant.
Chandrakanta, can you please help?
Good afternoon, everybody. Can I share the screen, or you will share the screen?
It is shared already. You can use the same if there are no changes.
Actually, I'm not able to see. If you give the control, I can share my screen.
Chandrakanta, can you help do that?
Yes.
Are you able to? Yeah, we are.
Are you able to see my screen?
Yeah, we are. Thank you,
okay.
Mahesh.
Actually, good morning and good
Is it
afternoon
visible to
again.
everyone?
So thanks for giving me an opportunity to talk in this TTTD. Today's topic
So
is
black
on
screen is
expectations on
appearing on.
management and
Mahesh,
orchestration in
I,
6G
I hear
operational
that
perspective.
people are not able to see your screen. They're only seeing a black screen. So can you please check again? I think uh, they're only seeing that you're sharing something, but it
Stop
is
sharing.
completely masked.
Share screen again. How about now?
Nope, nothing is being shared. So maybe what you can do is you can tell us the slide
Yeah,
number that you have
Chandrakanta,
locally. And Chandrakanta,
you
you can
can
do it.
open these slides.
Please share your screen.
Yeah,
Offline, I think Mahesh will let you know which slide to progress.
yeah, yeah.
Yeah. We are in slide number, which can you go to the next slide, Chandrakanta, so that I can tell Mahesh which slide we are on. Yeah, we are on the M&O economics slide, which is possibly slide
Yeah,
number.
basically we'll
Yeah, I
start
mean
with
that's the first slide. Please go
basic economics. We'll start with basic economics on management and orchestration. Because majority of the time when we talk about new generations, normally people will get attracted towards the RAN, particularly the waveforms, physical layer, and etc. kind of thing. The moment they listen about the management and orchestration, normally the interest will be very less. So basically, I just wanted to highlight whether the management and orchestration also has a role to play. So as per so the total cost of ownership basically includes two components. One is the capex and another one is the opex. So typically in a typical any wireless network, 30% goes to the capex and 70% goes to the opex. So if you in this figure, it definitely illustrates that the capex looks very small, and the opex is more or less invisible. But the actual fact is the major cost goes for the operational expenses, and here is the opportunity where we can optimize in the upcoming next generation technologies to reduce the opex cost, and hence leads to the reduction in the charges to the end customers. Next slide, please. So this particular slide basically gives the share about the RAN capex as well as the RAN opex. Basically, the capex distribution and the opex distribution. If you see, the highest contribution in the capex goes to the RAN, that is 50%, and the second highest contribution comes from the operations and support system, which is 20% in terms of capex. Similarly, in OPEX, 65% of the contribution goes to the RAN, and the second largest is 15% that goes to the operations and support system. So from this, it's very clear that operations and support system is also going to play a key role in determining the success of the technology as well as the decision of the price points. Next slide, please. This particular slide basically gives about the split of the cost in the telecom infrastructure as well as the management and orchestration infrastructure. Basically, I'm in slide 4. RAN basically consumes 60 to 70%, transport network 15 to 20%, and core network is around 10 to 15%. If you closely observe about the management and orchestration infrastructure, basically it focuses more on entities like NMS, orchestration platform, automation and analytics, cloud layer, service management and assurance. If you see the actual split, typically 10 to 5 to 10% of the total capex goes for this management and orchestration infrastructure. But in 5G advanced and 6G, it is going to increase slightly because of real-time on expectations on real-time orchestration, AI/ML integration, and multi-domain management. So basically, if you see, there is a expected increase in the management and orchestration infrastructure, which is expected to close to 15 to 20% of the capex. Next slide, please. This particular slide is talking about the market data. The SDN orchestration market is expected to reach to around 13.7 billion by 2030. Network automation and orchestration market is expected to reach 28.3 billion by 2033. Similarly, network orchestration market is expected to reach to 4.5 billion by 2033. The OSS and BSS and the core markets is expected to reach 105 billion by 2029. And system integration and infrastructure is going to reach to 4.83 billion by 2030. So from this data, it is very clear that there is a huge opportunity as the market is very huge from the management and orchestration point of view. Hence, key focus should also be there for management and orchestration. Now we will move on to the evolution of management and orchestration. How basically the management and orchestration evolved right from GSM till NR, 5G NR, and what is going to happen in 6G. In case of GSM, that is 2G, everything was actually manual operations. The NMSS was vendor specific, and the operation support system and business support system were very basic, and it's separated. Orchestration was not at all defined, and the key challenges during the GSM days was proprietary interfaces, lack of automation, inter-vendor interoperability was very poor. Then when we move to WCDMA, where the 3G case, basically we tried to adapt the telecommunication management network model from 3GPP, and we started using SNMP protocols, and also started introducing FCAPS model, basically the fault configuration, accounting, performance, and security. Here also the orchestration was not yet defined. It's all rule-based scripting for provisioning and all. The key challenges here also is complexity with multiple RAN and core elements, and also it's vendor locked and less interoperable. Still, the more or less the challenges were same from GSM days. When we move to LTE case, we started moving towards a centralized OSS, and also we got improved element management system. We started adapting SON, self-optimization networks. Basically, it's an initial days for SON also. And the orchestration, basically, we started with network function virtualization and SDN, and also the service orchestration using NFV Mono framework from ETSI. So here the key challenges were managing both physical and virtual infrastructure, because some entities were like a physical network function, and some entities were virtualized network function, network virtualized functions. So managing these two was bit challenging, and also interfacing the legacy OSS with new orchestrators was another big challenge. When we come to NR, that is 5G, we slowly move towards the cloud native and microservices based architectures. So here we started with end-to-end service management across RAN nodes, core network nodes, transport network nodes, etc. And also we started introducing closed loop automation using AI/ML. Of course, it's in the initial stages, not in the mature stage. And also standardization of service management and orchestration was taken up. Here the orchestration was completely dynamic network slicing, and full lifecycle automation of services was also possible. And here we started using ONAP and also RIC from the ORAN and the Kubernetes. So the key challenges in 5G was managing distributed, disaggregated, multi-vendor networks, and also the real-time orchestration under strict latency was also a key challenge. Now we will see here this particular slide is I'm in slide 7. This particular slide is predominantly from the network automation point of view. Here also more or less whatever I have explained in the evolution slide, it is mostly same. But only thing is we started introducing SON in 4G, and it is still not in a matured stage, as the intervendor or the vendor agnosticness is still limited. It's not full. That is another thing. And one more thing is The zero touch network and service management support is what is critical and key here. If we go to the next slide, slide number 8, this particular slide basically talks about what are all the entities that exist in 2G to 4G, and even it's applicable for 4G and even 6G. Many of the people normally thinks that management is only the RAN nodes needs to be managed, but which is wrong. Management is applicable to any physical and logical entities that exist in a network. For example, in case of 5G, you need to manage DU, CU. If it is 3GPP aligned, if it is ORAN aligned, you need to manage ORU, ODU, OCU, and also RICS. And also the core network elements like AMF, SMF, UDM, UDR, etc., etc. And all the application vertical nodes also needs to be managed. So managing the entire entities is the scope for the management and orchestration. In the next slide, slide number 9, basically, if you see in the earlier days, there was a separate operations service function for 2G core network and separate operation service function for GSM base stations and core network. Similarly, separate OSF for 2G radio, 2G terminals, sorry, 3G radio, 3G terminals, and 3G core network. When we moved to 4G and 5G, we started using the management orchestrator, where there was a NFV orchestrator which was able to manage through VNF manager and the infrastructure manager to instantiate virtualized network function, which will run on network function virtualized infrastructure kind of thing. And the DU part and the ORU part from ORAN is going to be realized as a physical network function, which also needs to be managed through the management orchestrator kind of architecture. When we see the evolution, there is also a upgradation from the NFV Mano perspective, as and when the the wireless technology also evolves. Mano also is evolved basically to align with the advancement in the technology. So in release 9, we had only the basic Mano architecture, and also there was the prime focus was virtualized machine based virtualized network functions. Basically, it's like a monolithic architecture and very simple life cycle management. When we moved to release 2 and release 3 of the Mano, basically it started focusing on interoperability and standard interfaces. Even emphasis was more on multi VIM and multi VNFM environments. Here, the support of performance management and fault management was also introduced. When we moved to release 4 plus 2019 to 2021, even the Mano started focusing towards the cloud native shift. And here they started moving from virtualized machines to containers, basically incorporated Kubernetes. Then dynamic scaling, stateless microservices architectures and all were supported. In 2021 and 2023 release 4 plus release, we started incorporating automation and intelligence and also policy driven orchestration, then predictive scaling, fault prediction, network slice management and all we started supporting. Even multi-domain orchestration started incorporating across edge, core, cloud, etc. In 2024 and 2025 release, we started supporting intent-based interfaces for high-level service goals, end-to-end slice orchestration across RAN, transport, core network, etc. And also started aligning with ONAP, then ORAN, SMO, and other open source. When we move to the slide number 11, this is basically the crux of the entire topic. This is operators' expectation on management and orchestration in 6G. Basically, we have a set of categories under which some expectations are kept from the 6G point of view. From the automation point of view, basically, we expect the full life cycle automation, right from design till the termination of the management instance, basically instantiation, scaling, and healing also. Basically, we expect AI native, even though we want to see both the classical automation approaches and also the AI enabled approaches separately by providing enable and disable kind of option for AI enabled. Then closed loop automation, zero touch operations. Basically, we want to minimize the human intervention almost to the 0%. When we talk about service management, we wanted a predictive kind of management. So far, it is event-based and reactive kind of management. So going forward, we want to predict and resolve the possible occurrence of the issues well in advance. Then intent-based. So far, in the intent-based, basically, operator is going to provide the business goals, and from these business goals the AIML model is going to generate the configuration, the needed configurations and the decisions which needs to be adapted for deploying and managing the networks. Then SLA aware and digital twin powered. In case of digital network twin, basically we are going to have a replica of the network, and we will use that replica to basically test and simulate some of the scenarios before incorporating into the commercial live network. We cannot do the trial and error method on the commercial network. So digital network twin is the game changer from the management point of view. Then multi-domain orchestration. See, majority of the 6G is people are talking about ubiquitous coverage, ubiquitous connectivity, basically covering the connectivity in the space, air, ground, sea, not a deep sea, but at least on the sea, and also edge, core, cloud, and slices. So there should be a unified orchestration across space, air, ground. Because when we see in some of the operators who are having 2G network, 3G network, 4G network, 5G network, they have a huge number of management entities itself to manage these networks. So that's why it's very difficult to manage such a huge number of management entities rather than the mobile network entities. So even if we can start incorporating these kind of NTN, terrestrial network and non-terrestrial network, it will become even more. So it is always better to have a unified orchestration solution so that from the centralized location, everything can be managed as much as possible. From the security point of view, basically, it is zero trust compliant, and here also AI enhanced and built-in kind of security needs to be added, needs to be supported, and the quantum threats needs to be addressed very efficiently. Otherwise, we are going to fail even in 6G. Then the architecture perspective, it should be composable, modular, and function as a service needs to be supported. From the AI/ML category perspective, we are expecting a federated and distributed kind of role. Basically, as the previous speaker was mentioning, data can be available at different entities, and some data can be shareable and some data cannot be shareable. In those cases, we need to have the federated AI modeling also, distributed AI modeling also, so that both the scenarios can be addressed efficiently. Then explainable AI. Whatever autonomously the decision is taken by the AI models, we need to understand why the decision has been taken. So the explainable AI is going to give the detailed explanation about the decision taken. So similarly, the real-time AI at scale and AI as a service. With respect to the performance, basically 6G is going to have millions and billions, not millions, it's billions, few billions of connected devices. So all the devices needs to be managed by the management and orchestration in 6G. It has to manage the connected devices right from extreme edge devices, core devices, and even other relevant devices. And also it should be ultra reliable and low latency. Basically URLLC or hyper RLC is the terminology used in mobile infrastructure, but similarly in management also we have to have ultra reliable and low latency because of managing such networks is very critical. So the expected latency of orchestrating is less than 1 millisecond kind of thing. If I move to the slide number 12, it is just the indication that 6G is going to adhere to sustainable development goals. So management and orchestration also supposed to fully adhere to the SDG Sustainable Development Goals. Basically, the prime importance is on energy efficiency, spectrum efficiency, and resource efficiency, and the sustainable democratic green global communications for tomorrow. So all these things has to be addressed by the management and orchestration in 6G. Basically, in slide number 13, I'm going to focus on key values. When we talk about we have to adhere to SDG, we need to focus on the key values and the key value indicators. Basically, this represents the societal and economic goals
Next
that
slide,
6G
please.
networks and beyond are expected. Basically,
Sorry, your slide is not moving. Chandrakanta, can you please move
it
to
provides the sustainable.
Thank you. Mahesh, please
Basically,
wrap up in 1 minute. Thank you.
pardon?
Please wrap up in 1 minute.
Okay. The key values here basically focuses on sustainability, the fairness and inclusiveness, trustworthiness, human centricity, economic values, and invitation. Basically, it has got a different purposes. Basically, if you go to the slide number 14, there is a tentative list of key value indicators under each of these.
Can you just take through the next slides just to flash to the audience what does next slides were, right? So he's defining some requirements for MNO and 6G. Okay. Next one, again, he lists a lot of requirements from an operator perspective. Okay, next slide. Just to quickly show to the audience that what Mahesh was covering. Next slide, please. Yeah, same. I think let's keep going to the next slide. Yeah. I think his objective was to give key value indicators for 6G and also capture some potential requirements that Jio sees as an operator for management and orchestration domain. So I'm sure it will be difficult for Mahesh to kind of join back and resume his presentation. So I'd like to thank Mahesh because the session is recorded. He may hear it later. For taking us through this journey from the economic side and also the total journey of the evolution of the management and orchestration systems to a more unified view that we have today, and also laying out the expectations in terms of the 7 categories, and also describing the KVIs and the requirements. So I think we should make this presentation available to the audience after this session, so that more questions and interactions can happen within TSDSI based on this presentation. So thank you, Mahesh. So let's now go towards the next keynote speaker. Yeah. So our next keynote speaker is from Nokia, Ms. Nurit Sprecher. She's going to deliver a keynote on catalysts for unlocking 6G potential, intelligent exposure, and cognitive agentic automation. So Nurit is an HC fellow, and she's a multi-award winning technology leader with 30 plus years of global telecom experience. She heads the Nokia's network automation and exposure standards domain and is distinguished member of the Nokia Technical Committee. So she has a very strong track record in driving future network architectures, automation, exposure, and standardization, shaping the evolution towards 6G and beyond, with a focus on enabling innovation, intelligent network and services, and monetization. So I welcome Nurit to this and request you to take the floor to deliver your keynote.
Okay, thank you very much. Let me share my screen. 1 minute. Okay, can you see my slides? I'm moving now to the presentation one.
Yeah, we can see your slides.
Okay, 1 minute. Okay. Thank you very much. It's a pleasure to be here, and thank you, Nirans and team, for inviting me to present. 6G is approaching, and I think it's important to understand the opportunities with 6G. And today we will talk about catalysts for unlocking 6G potential, specifically with the focus on intelligent exposure and the foundational technologies like cognitive and agentic automation. So when we talk about intelligent exposure, I think it is very important to understand what we're trying to achieve and what it is actually. And the intention with exposure and programmability is to make the network specialized to support value creating use cases and business opportunities, and of course to monetize the 6G network. So let's a little bit sharp the definition and applicability of exposure. So I would like to propose that exposure, network exposure, is providing the on-demand access to three services: network data, resources, and control. And when we are talking about data, it's about information from the network that can be raw data, it can be abstract, it can be aggregated, it could be per UE, analytical, or location. And we're talking about control services, which is the ability to influence the behavior of the network and the resources. And if you think about it, at the end of the day, every service that we expose is actually converging either to data or control. I provided additional a kind of service, which is resources, because of the nature and the value of that service. This is assets within the network, such as cloud resources, connectivity, bandwidth, slices, etc. But if you think about it, resources is just another abstraction level of data and control as well. If I want to get connectivity from here to here, I actually ask with control to set up connectivity from here to here, and then I get the data, the endpoints, how to use the resources. So resources is another of abstraction level of data and control. But since it's important components, I decided to keep it as one. But at the end of the day, all the services can be mapped and converted into these three fundamental services: data, resource, and control. And these services help to empower operators, developers, and partners to innovate and create value for vertical applications. And we can do it by the following. We can expose services for the use of the vertical application. And for example, developers can help to optimize the vertical applications, for example, being more network aware. So I can be aware of available predicted bandwidth or whatever, and then optimize the video delivery, for example, to better fit the available bandwidth. I can actually also use the services to provide fit-for-purpose network programmability and specialization. When we talk about programmability, it is about the ability to customize and optimize the network performance through own or third-party software. So for example, we can open up the network or the SMO, the management and orchestration, to third-party innovation to help us to customize the network to support particular vertical use cases. And of course, data help us to enable AI agent and enrich AI training. So this is, having that definition in mind, it can help us a lot to simplify everything that we are doing. So just to give a little bit of example about exposure and programmability, if we think about UAV-based monitoring and inspection, how it can be enabled by programmability. So for example, I can have a control services that are used to specialize the network, for example, for live video streaming of the UAV, or to have a remote control that I can actually control the UAV, or have aviation grade connectivity, or I can have quality on demand, or even to support SIM swapping. And then I can have data that is exposed from the network that can help me, for example, to understand the predicted latency or throughput per applications, or to understand the accurate location and precise positioning information. And another option is to expose the resources. So for example, I can expose edge cloud resources where I can actually deploy my applications to have anomaly detection or scene analytics or whatever to support better performance. If we try to understand what it actually provides, I can tell you that it's amplified the network effects and innovation for growth and maximize return of investment. So just think about it. I have the supply that provides the network. they provide expanded network services. The network services are actually used by a global platform like Nokia Network as Code, for example, to abstract the services and then make them more valuable services to the developers. So actually we provide simplified and abstract services that the developer can use to help the vertical applications. The developers then provide innovative applications. This creates a lot of attraction, and then we have growing user base and proliferation of applications. So we get more money from that. That means that we have growing developer community because we need more and more applications to support that. And that means that we need to invest more in the network and to have increased network provider participation and investment. And actually, if you think about it, it creates an effect, an innovation in a kind of dynamic supply-demand ecosystem. So we get more users, more applications, more developers, more resources and networks, more innovation, and more revenue. If we look today at the situation of 5G, it's a little bit tricky. We can expose today, okay, definitely, and we can program today, but it puts some challenges on and burden on the implementation and the way that we can innovate and monetize it. So look at the network. Everything is featured, complex silos, exposure architecture. We don't have a common, unified way how to access the network services. And also the fact that it is being developed in silos actually hinder holistic support for the use cases. So I don't see the end-to-end use case in one place and understand what does it mean and what network services I can actually offer in order to support that and even offer that in optimal way. The consumer of the network services don't have unified experience how to do that. They need to, and we don't have a plug and play. They need to tailor the particular application for the environment that actually propose the service. And we don't have flexibility in the network. We don't have access between the network domains. And if I actually want now to expose services, for example, if I want to expose something from the RAN, and if I want to enrich that and have some core network information in the RAN, I don't have a way how to consume the core services. This demands extra effort for the cross-domain integration. What we do today in Nokia, in order to ease that, we actually have our Nokia as Code that serves as a kind of API aggregator that take all the network services and abstract the complexity to the vertical applications and provide them easy access to enrich value-adding network services. But if we could do it even better, even we could also ease the integration of the network as Code with the networks, with different providers, and actually provide additional value to the consumers. So if we think about what we would like to see in 6G, in 6G, we would like to see, and I have a mistake here, it's a typo, I will delete that and I'll send an updated version. 6G really presents opportunity to do it better. What would be the key success factor that are relevant to standards? First of all, if you want to be it useful, it needs to be used, and we need to ensure that we can have scale and global reach. We need to ensure that we support value-generating use cases. We don't expose because we have the data or we have the control services or we have the resources. We expose because there is demand and that there is a demand for that services and there is a value in the monetization of that services. I want to create APIs that are developer-friendly and intuitive. I want to ensure that I have network security and privacy measures. And I want to ensure that I have unified approach and global standards, and that I can support diverse deployment options. And I think this is key for 6G to ensure that we have the flexibility to support different implementation and different deployment options. So if you think about the architecture design principles, I would like to have an architecture that is streamlined and provide unified exposure architecture and experience. I want to have holistic support for use cases following top-down approach. I want to have access to invaluable data. We talked about data before to fuel the innovation. And I want to have flexible distribution of the intelligence with inherent exposure to enriching information within and outside the network. if I try to navigate a little bit the evolving industry landscape for that, and now I try to put it in a very abstract level where I have the network and I have the value adding a network platform on top of that, and then the vertical applications. So the vertical applications requirement usually coming from organizations that are working to support the applications like the metaverse form, the 5G AA or 5G ACAA, or maybe in 6G we will have new forms, and of course the developers themselves. So it's very important to engage with the developers to understand their challenges, their needs, and their requirements. And then we have the value-adding network platform. GSMA has defined the common platform, which is called operator platform. And then we have the vertical application-bound APIs that we expose towards the application. And these are defined, for example, in Camara or in OPG supports some, CMEX supports some, SE6 trying to get into that, even though I would say that they are limited in what they can expose because the 3GP network doesn't cover the entire network. TeamForms support the operational APIs. And then we have the APIs that are coming from the network APIs. And this is spread across the cloud domain and the different technological domain, and see how many organizations are participating in that. And these are just the key organizations. And to have the common exposure framework, this is 3GPP has defined the CAPI framework, and think this is something that we can adapt as a unified exposure framework for 6G and evolve it further to make sure that we can use it across the network. So what is our ambition for the 6G exposure is that we want, first of all, that this is a 6G day one topic that we can monetize. We want to actively engage with the vertical ecosystem to explore value-creating use cases, to shape the requirements, the architecture, and common services end-to-end, to see it end-to-end. We want to drive a simple future-proof architecture that is able to adapt to evolving requirements and technologies while promoting a unified consumer experience to streamline the process and to maximize the operational efficiency. And a key to achieve that is to foster coordination across the broader industry landscape. So thinking about exposure and how I can actually enable the evolution and unlock the opportunity of exposure, it's very important that we evolve towards agentic network, which is fully autonomous, intelligent, programmable, and adaptive. And the foundational technology pillars are cloud native, intent-based, autonomous, cognitive, programmable, and service-enabled network and IT. AI-powered analytics and prediction services are key for that. Security, native privacy, and automated processes for publishing applications to marketplace. So to support that, we need to accelerate the evolution towards agentic networks built on the foundational technologies for intelligence, autonomy, and programmability powered by AI and ML. So let's see a little bit, and I need to rush up. What does it mean? So what is the ambition for the 6G is, and I think we heard that before, we want to achieve optimized TCO, guaranteed services, speed of delivery, and new business opportunities. And we want to do that by embracing stealth-X capabilities, self-fulfillment, self-assurance, self-optimizing, replacing manual operations with adaptive autonomy for deploying, managing, and optimizing the network resources and services, and ensuring 0X, zero weight, zero touch, zero problem experience, and to open the network to third-party innovation to help us to specialize the network. And we want to have a holistic autonomous operation, which is enabled by agentic AI, leveraging intent-based networking and cognitive control. And it's important to realize that automation spans the business level, the service level, and the resource level, as well as various technology domains, RAN, fixed access, core, transport, cloud, etc. And when we are looking at automation, we need to look at that holistically to make sure that we have common principles and enablers to ensure flexibility, agility, and adaptability. Now, it's not that we don't have automation today. We have a lot of automation today. So what is missing actually? First of all, to make it common, we need to establish it as a day one. And since we want many aspects to be native, we need to establish it as a day one topic. So we have a lot of the enablers already today. but these are actually the paradigm of capabilities that underpins the cognitive autonomy. But many of these are available today, right? So what we need to make sure is that how much time I have, I just want to know how speed I have to be. So first of all, we have Audio Management Foundation with enhanced FCAP service and resource orchestration, model-driven APIs. We need to have access to invaluable data and observability. We need to have AI-powered analytics, prediction, machine intelligence. We can get assistance from the network digital twin that can simulate network scenarios and decisions. And on top of that, we have the closed loop and the intent that is coming. Now, it's very important to understand that a lot of that is available today, but what we are missing today is more about the commonality, about the flexibility, etc. So let's a little bit see what we can do. And maybe before that, there is a lot of discussions in the industry at the moment about agentic AI. I would like to offer that instead of talking about agentic AI, we start talking about agentic automation paradigm, which is the foundation to achieve cognitive autonomy. And think about
Thank you. 2
I
minutes.
didn't hear you. 2 minutes. Okay. So
Yeah,
so maybe I will do that very quick. So if you think about agentic automation, it's actually combines a centralized and distributed AI-powered autonomous engine with intelligent agent to enable intent-driven, flexible, adaptive, and scalable automation across 6G network and services. And what we actually get is we get intent that is coming from the owner. It's coming to the engine interprets the high-level intent and orchestrated associated goals across domains, delegating them along with related intents to agent to execution. The agents make decisions and act autonomously to fulfill the delegated goals guided by the intent. They learn, they adapt, and they collaborate across boundaries. And we have the feedback loop that enable learning, adaptation, and cross-layer, cross-domain optimization. And what we need to ensure is that we can support both centralized and distributed intelligence. So just as an example, the autonomous engine can be the end-to-end service operation that fulfill, show and orchestrate the network services. And then the agent is the management domains per technological domain that orchestrate the resources to support a particular domain-wide service. And then we have the network, we can only also operate autonomously to satisfy the delegated intent. What is the granularity of the agent when we talk about the network? This is something that we need to be very, very careful, because if we start talking about every network function becoming autonomous unit, we are breaking the all autonomous operation philosophy that actually wants to hide complexity. We want to look, for example, at the core network as a whole, and to provide it intent that the core network knows how and do it. And if we need now to understand how the network core is actually built, we're actually a little bit breaking that philosophy. I will not go into that. You will have the slides because a lack of time. You can look at the key requirements and what is different in 6G and what are the design principles. But if you allow me just one more minute. So I think the key design is to provide simple, flexible, and extensible architecture with common enablers across all domains, effective management of complexity with clear division and responsibility and abstraction, having native exposure, autonomous resolution of intent conflict, dynamic composition of closed loop, management and governance of the AI, native security, and more important, support for diverse implementation and deployment scenarios. And this will be the value for 6G, and we need to enable that and not to pose and to dictate particular deployment options. And this is the last slide that I would like to show, is that the industry landscape for automation is very complicated, but what we need to make sure is that we have a harmonized and symbiotic landscape. And if you can see, the engine is defining different organizations, the agent, the domain management domains are also in many organizations, and the agent also. Now, if we want to do it appropriately and we want to support all the needs for 6G, we need to understand what is the role of each key organization and to enable effective collaboration to maximize the complementary contribution, and also to ensure that we have common enablers and that we actually can allow streamlined, flexible deployment option with the flexible integration of the intelligence across it. Yeah, I'm sorry I didn't manage to go it all, but I hope you can look at the slides later, and I'll send you an updated version later.
Thank you. Thanks a lot, Nurit. Thanks for taking us through these aspects about exposure and automation in 6G and the success factors and the principles that will guide guiding principles for enabling the evolution of exposure and automation in 6G timeframe. So thanks a lot for presenting your views, and we hope that 3GPP and all other complicated, as you showed the landscape, right? So many SDOs will work together to realize the 6G dream. So next we will go to the last keynote of the day. I'm very happy to welcome Mr. Rajgopalan Rajappa, the CTO of Tata Elxsi, and he'll deliver the keynote on agentic digital twin-based orchestration for 6G networks. So Rajaji, as we fondly call him, currently serves as the CTO of the communication technology and platforms at Tata Elxsi. He leads solutions for telco and automotive industries in softwareization, orchestration, digital twin, connected vehicles, and edge solutions using open systems and open platforms. With over 25 years at Tata Elxsi, he has designed RAN systems, scheduler algorithms, and software stacks for small cells and broadband wireless communication system. So I welcome Rajaji to please take the floor and present his keynote. Rajaji, being the last keynote speaker, I know you have immense pressure on the time, but I hope you will make it in time. Thank you so much.
Thanks, Nirant, and thanks DSTSI for giving this opportunity to be here along with the esteemed panelists and distinguished speakers. And so it fits into the logical place when the whole session started with the data, importance of data exchange, standardized data exchange, moving on to the importance of orchestration, and then autonomous, intent, and agentic. So my keynote touches upon agentic digital twin orchestration for 6G networks. Can we go to the next slide, Chandra? So just a quick overview of what we are going to cover here. An evolution from 4G to 6G, how it is becoming data-driven, AI-native, digital twin-driven, agentic orchestration. What are the possible part of possibilities from open systems and open architecture? There is a comment on there. And a quick comment on the 6G network. What is the digital twin universe? What are the things which can be modeled based on data-driven and AI-driven approach? And how the RAN digital twin can play a significant role in terms of the business and energy impact. Mr. Mahesh touched upon the extent of total cost of ownership the RAN is having in terms of both operations and CapEx part of it. I would like to even add upon the energy part. Energy also, again, 60% is or more is contributed from the RAN. And a quick architectural take on how the multi-domain, multi-agent orchestration, it's logically follow through the conversation from what the Nokia esteemed speaker talked about. And we'll talk about the agentic digital twin. Does it have any challenges and what problems which are there? How some of the standardization approach still has to move towards homogenizing the standard and make this as a reality. Can you move to the next slide? Yeah, this is a quick evolution or revolution of 6G from 4G into this. 4G is purely a packet-based end-to-end packet switched. In 5G, especially on the standalone architecture, cloud-native, service-based architecture, where the automation and orchestration was made possible, and then the NORAN architecture comes to work. And the 6G, the way from open systems and open architecture, we would like to see is pure AI native, as every other esteemed speaker talked about. It needs to be AI native end-to-end. And the RAN part of it also has to be expanded as open AI RAN from ORAN. there are possibilities even to have the transmit signal chain, receive signal chain, and then inter-RAN, neighborhood RAN optimization options are possible if really the potential of data and data-driven paradigm and data exchange paradigm, federation paradigm is really, really being leveraged here. I think one thing I would like to call out explicitly in the data-driven, AI-driven paradigm, the owner of the data is going to be the telcos. The telcos have a lot of freedom to govern the MANO and orchestration and data-driven orchestration like the way Mahesh had put across, but again, I'm amplifying that part. And then the opportunity we have for bringing down the cost of the 6G by extending the CI/CD capability, continuous integration, development, and continuous learning capability into the RAN domain. I think that's a huge, huge opportunity from the architecture standpoint. And it will, in my opinion, it will drastically cut down even the network build-out cost of the technology itself. In the 5G, it's all vendor-driven, vendor-built system. There's huge cost component associated with it, with an ability of software and then machine learning model and algorithmic driven and data driven approach possibility. The overall cost of bringing down even the building of the entire 6G system can be brought down. And from intent-based orchestration, it can potentially move to the digital twin and agentic orchestration. That's the opportunity we have. Can we move on to the next slide, please? So since already the speakers had covered about the agentic part, so the agentic digital twin, only the one option is digital twin is a replica of the physical system. Then we can extend the replica to a multiple dimension when the data-driven approach is being taken. It can have a replica of RAN, replica of transport, replica of core, replica of network slice, replica of particular dimension, KPI dimension. It could be of energy efficiency, it could be of a topology. These are the possibilities the digital twin has it. It's an interesting options when we are combining the sensing through the telemetry, plugging the data in from the data lakehouse, and then one can trigger the orchestration or action, then it becomes a digital twin based agentic orchestration. So that's the way we are looking at the 6G's possibility. It's an interesting, another concept called a spiral twin. The digital twin is just a passive replica. Spiral twin is a learning. If you have a machine learning models built into the digital twin, it can also act as a spiral twin. Can you move on to the next slide, please? So this the 6G digital twin universe. So the entire physical network can be modeled, including some of the service elements like beamforming, MIMO, the programmable RISC configurations. The most important thing being the channel digital twin, and even some of the deployment context like HETNET configuration or the macro, micro, pico, indoor. All this configuration can also be modeled at appropriate level. It could be on centralized, federated, distributed. All this combination exists. It's a considering the time point of view, time constraint. I'm quickly gathering this, but it has an enormous potential to model the individual element, individual devices, the topology of the entire end-to-end network, then even the service elements and like this. The most important thing, the digital twin and intent-based orchestration, agentic orchestration lends itself to modeling the security, the threat surfaces, the open surfaces which are available with open and a lot of machine learning models, AI models, CI/CD comes in. The systems are exposed to huge security and vulnerability part, and that also can be modeled through digital twin, and we can have agentic workflows to do a testing and validation and simulation part. The most important thing in this particular slide is to look at the AI and data pipelines. It has an connection to what Dr. Inder talked about. It is still not standardized. There has to be a standardization for enabling the data exchanges, data semantic definition, KPI definition. The multiple levels of standardization needs to be defined within the system, across the system, data exchanges, and data pipelines. Can you move on to the next slide, please? So most important thing in any mobile technologies in the RAN, I just try to again refresh what Mahesh had talked about. The CapEx is more than 60%, OpEx is more than 60% in the RAN. Even in the energy, when we are talking about sustainability as one of the prime goal of 6G, the RAN side consumes 60%, and on top of it, you add the regulatory spectrum licensing fee, runs on billions of dollars. So there is a huge potential in applying the machine learning algorithm within the system and across the system, localized optimization and global optimization to bring in the spectrum efficiency. And here, this starts from experiential channel modeling. Typically, channel modeling were restricted to the test and measurement equipment. Here, the data-driven channel model makes empirical model possible, and then the algorithms which are machine learning model based can learn and adapt to the individual channel conditions. Those are the possibility exist to optimize the resource usage in the radio side, resource usage in the spectrum side, enhance the customer experience overall, quality of demand, network slices, the SLA requirement can be met. Then again, the possibility of the full topology, neighborhood optimization, apply game theoretic model to do the global or local minima, local maxima optimization possibility exists. The standard MIMO beamforming we already discussed about. Yeah, we can go to the next slide, please. So this is the bigger blueprint from an architectural standpoint, and some of the points the Nokia speaker had already talked about, in the sense that how the entire end-to-end network can be replicated as a data-driven model across multiple domains in the RAN digital twin, transport digital twin, core digital twin, and service level digital twin. And they ingest data from two different data sources. The one data source being the live system. The live system will be connected to the EMS and NMS system or through the standard protocols. The other bigger data source is the telcos data lakehouses. So based on this, the machine learning models can act on multiple perspectives. The digital twin could be used for planning and estimation purposes before the services or the devices has to be built and deployed. The digital twin could be leveraged for operation perspective, for AI ops, for predicting problems, for predicting the capacity expansion, and so on and so forth. So it could be even used for monetization purpose. What kind of the usage pattern from a different customer for upselling and cross-selling, etc. So one of the key thing in this agentic orchestration based on digital twin is you could see the machine learning models are primarily recommended to be the classical machine learning models. It could be DeepQ and then LSTM, depending on the use case, whether it's a RAN on transport and so on and so forth. The reason here is that the network analytics, unlike the common bus, LLM is not the best fit for the network analytics, which are based on the numbers, which are based on the telemetry. The classical machine learning models with some of the advanced algorithms like game theoretic, when it comes across the multiple system and neighborhood, etc., or even something like the DeepQ algorithm would be doing a better job. The LLM can be used for the customer reported problems, and then for something to do with user manual references, resolving some of the customer reported problem. So that is the way the LLM being the second order importance here, even the sustainability goals could be accomplished here. So that is the biggest take on. Not necessarily the agentic orchestration needs to rely on LLMs. Agentic orchestration still can work on classical ML models, which are more suited for network analytics and telemetry. That's the bigger take on this. Can you move on to the next slide, please? So this is more of, again, from an architectural standpoint, extending the CI/CD from not just on the cloud native functions which are running on telco cloud, or even extending to the WAN DU and C alone. It can extend. The idea here is, since it's going AI, the AI native 6G paves itself for a complete cloud native machine learning algorithm based approach, even on the physical layer. The CI/CD can be extended to the physical layer, so it can be the continuous integration deployment is being augmented with continuous learning, and continuous deployment can extend to recaps, DApps, and even into the physical layer, transmit, and single chain. And this is a way, there's a point of view that even the build cost for the technology itself can be brought down. So it's not just on the post-deployment and optimization. Even for building the technology for open systems, it paves way for a larger collaboration between industry, academia, and then the open source community. Can you move on to the next slide, please? So is this model the data-driven, AI-native, digital twin orchestrated 6G? Does it not have any challenge? It has huge amount of challenge. There is heterogeneous data coming from multi-vendor system, and it has variety of sources. So it needs a lot of standardization, as we are already talking about. The synchronicity between the digital and physical, there are considerable amount of issues there. Then the cost metric. The cost metric can be handled by sharing of data, federation of data, then sharing of machine learning model and exchanging of this. A lot of things depends on how all of this standardization of data exchange, over-the-air update, KPI standardization, data exchange standardization are being standardized. So that will, so we have considerable amount of challenges, but still, I think with the standardization body, open source community, there are possibilities, and we are hopeful of solving them. Go on, please.
Rajaji, if you can wrap up in 1 minute, that will be great. Thank you.
Sure. Thank you. So this is the last slide. So this gives the possibility of a new business model, because monetization is the biggest challenge. With a ORAN, RU sharing architectural model, even the RAN sharing, Spectrum as a service kind of a model are possible. These are the models both the industry as well as the standardization body may possibly needs to dwell deeper on data sharing, spectrum sharing, RAN as a sharing model. And that gives a lot of possibility for making the whole the network build and operating of the network to be much more cost effective. Can you go to the next slide? Yeah. So thanks everyone.
A lot. I think you took us through a very valuable journey of agentic digital twin, and also touched upon spiral twin, multi-domain, multi-agent digital twin for 6G, and also touched upon various different roles of AI in different aspects of the network, and also stressed on the standardization for software service lifecycle management and the business opportunities in the operating model innovation that is required. Thanks a lot, Rajaji, for your keynote. So now next, I think I will hand it over to Pavinthanji. Pavinthanji, please take over for the special session on the role of data. I think that is coming up very prominently, as we have heard, in this domain of how to monetize, and especially be able to do zero touch let's say automation, achieve zero touch automation, I think data also plays a very key role. So I hand it over to Pavintanji to preside for the next sessions. Thank you.
Thank you very much, Nirant. This session will focus more on the data aspects. So going forward in 6G, we will have the role of data being prominently felt. So without further ado, because we are running a little late on time, so I will go with the speaker introduction and we will invite the first speaker. I request the speakers to approximately take about 10 to 12 minutes. That is the time the Secretariat is suggesting to close the session so that the next session can start. The first speaker is Chandra. Chandra is a Chief Executive Officer of Fiware Foundation, a global non-profit organization fostering open source technologies for smart cities, data spaces, and digital public infrastructure. With over 26 years of leadership experience across the digital transformation landscape, Chandra has played a pivotal role in scaling open and interoperable ecosystem that empower governments, industries, and communities worldwide. Thank you, Chandra. Looking forward to hear from you. Thank you. Welcome.
Yeah, hi. Thanks, Ravindra. This is nice to meet you all. This is Chandra. I'm the CEO of Fiware Foundation, and thanks for the introduction. Yeah. So we can. I'm actually going to touch base about the role of data in the management and service delivery as the title subject, and I'll try to be as fast as possible. I'll go through the first the introduction of Fiware and what are the contributions have been in the area of this lead. So let's actually just to give a brief about Fiware. It has a European roots. It started back in 2008 by the European Program for Digital Sovereignty at that time. So it actually is a smart framework, so highly adapted though in smart cities because of very high funding available during that time. But there came a framework in 2011 when the funding is finished. Unlike many of the projects in Europe, European Union funded projects, this asset which came out of this massive project of 500 million was very seen as a very valuable asset, and the community voluntarily kept it alive for coming 4 or 5 years. In 2016, the commission came together with the private entities who are investing in this asset, decided to start another program to create a legal entity which takes care of this community and steers the community so that the business interests are kept. So that's where actually the Fiware Foundation's legal entity has been incorporated in Berlin in 2017. So the legal entity's form is very, very big, actually, so very complicated. The definition is, to simplify it, it's actually a public entity for a public good by created by the public entities. So as the EU Commission and some private entities and also the German government was involved in creating this. So the Fiware core technology is based on the NGSI-LD, and it was initially called NGSI 9, NGSI 10. This NGSI has been initiated in 90s by Ericsson and Nokia, but that has evolved into NGSI 9, 10, then version 2, and now it's a linked data. So combine that with the smart data models and the context brokers, that lies the core of the Fiware technology. And it actually goes beyond open source. So we have 3 core principles on Fiware. Is that it goes beyond. It has to be an open source. It has to be based on open standards. Open standards means everyone can access freely without any hurdles. These standards and the core, all the components which consist in Fiware ecosystem are non-vendor locked. So it is important actually that they are permissible. The domains which has been adapted are agri-food, mobility, cities, energy, and water. It's globally adapted, so 60% of its adaptation is outside of Europe now, significantly in South America, Japan, South Korea. And the Africa is moving very aggressively on this adaptation side. We can go to the next slide. Yeah, so there's a difference between the FiveAir and the FiveAir Foundation. So FiveAir is the technology and the community which is behind, and the assets belongs to the FiveAir community. The developer community, which consists of 10,000 developers, very active in this area. The FiveAir Foundation is a non-profit organization. It has a regulatory board. It's also a trusted organization where the FiveAir community can be steered or ensure that we give a full support to it. Then take it forward. Yeah, take it forward. Next slide, please. So the core principles are actually the open standard, open source, and non-vendor locking. The community and governance lies at the core of it. So it falls inside the digital sovereignty and ecosystem empowerment. The capacity building is one of the key issues we also work on. That is that we strongly believe that the capacity should be built locally. So the local ecosystem, wherever it is adapted around the world, has to have enough expertise and trainings and skills to take these platforms forward. So we do a lot of training, a lot of local capacity building across all around the world. So this is actually one of the 4 core principles what we have. Yeah, we can take the next slide, please. So it's by the community for the world. It's a global open source community. SMEs, cities, and integrators around the world. FiveAir has iHubs, hackathons, trainings, lectures, certification programs. We have 49 innovation hubs around the world, all the way starting from Chile to Japan, Norway to South Africa. These 49 hubs create actually a local ecosystem, provide services for the local SMEs, and all these kind of activities are done in there. So this is the key, which is also we strongly believe that the local capacity should be built for the sustainability of the platforms. It has to be locally owned and should be owned by some SMEs. Yeah, we can go to the next slide, please. Yeah, so this is I call it a FiveAir house. The foundation has the governance and the models. We have a technical steering committee, which is actually started in 2011, even before the FiveAir Foundation legally got incorporated. It has been driving itself. It's a very autonomous, independent body. Work together with the board of FiveAir Foundation. And we have a whole ecosystem of members, businesses, cities, the end users around the world, universities adapting to this ecosystem, and all the assets are in the community. Including the innovation hubs. What we are not is a specification or a standardization organization. So we use a lot of specifications which are we think are neutral and open and standards. We also contribute back to a lot of specifications. So what it is a framework which is available, which can be used, taken, and used for even for creating a proof of concept right away. So all the deployment scripts and everything is available, but of course this is not a production quality. So a local or some organization or the local ecosystem has to be built so that the platform can be further harnessed to actually have an SLA. So with this foundation, we actually do a lot of work together with European Commission, decision makers, and standards development organizations like SenseNLEC and ISO and various HC organizations. We are very active on this area. We are in the process of creating the business community, which is not there yet, which consists of our business entities who have been funding us. We also extended this a little bit to actually accommodate something called an international commons, where we basically launch may not be a FiveAir specific related technologies, but something which follows the 4 core principles of open source, open standard, non-vendor locking, and enables the local ecosystem projects to this. We have launched just a couple of months ago. We are evaluating a couple of actually already 5 projects in this process. Next slide, please. So FiveAir falls in the belief because of these 4 principles what we have. on the core, we fall under the 11 category of SDG goals of United Nations. That is the smart, sustainable cities and communities. So it is not only that the platform is created; it needs to be maintainable. So our concept, our core value of creating the local capacity enables this. So we try to provide the sustainable maintenance for this platform. So this is our core. Then we can go to the next. So we have a 9 board of directors. We have 31 technical steering committee members. The steering committee members have been elected based on the meritocracy and the democracy concept together. Then we have assigned 9 scientific advisory boards from well-known professors around the world. Yeah, and more than 10,000 developers at this stage, 600 regular contributors on the technology and the component side. We have 49. Three iHubs are on the pipeline still around the world. We have more than 160 member companies. Actually, this number is more than 200 now. We have more than 600 actually individual members, but and also partnerships at the global level with key organizations like IUDX and Digital Agency of Japan and Korean Digital Agency and also various organizations. Next slide, please. So the assets are, we have more than 60 components which can actually be used in a platform. We have more than showcases, more than 200 showcases where the 5-year based offerings are available in our showcase. Hundreds of open source projects as of now we have been involved in, more than thousands of deploys. We don't know exactly how much deployments we have. Wherever we go to the local ecosystem and we talk to them, we realize that our knowledge is only 10% of their deployments at this stage. I think it's very permissible that they don't need to inform 5-year Foundation or be interactive with any of the foundation members or a community. They just can go forward and take the platform and start using it. Next slide, please. So the core technology is the data management, data sharing, data exchange, and data models. So it's basically all the way goes from the spectrum.
Chandra, if I could conclude in that would be great.
Yeah. All right. So we can take it forward then in that case. So.
No, I mean, you can just conclude with in a minute. Yeah.
Yeah, we can take it forward. So next slide, please. I think we don't have time. So. Yeah, data as a cornerstone for 6G services. So, and I think ultra reliable autonomous context aware networks. So the context is core even for the AI nowadays. The 5-year contribution has been NGSILD smart data models, open vendor neutral. Semantic interoperability across the domains because it's not about the single domain anymore. So it's an interoperability which is needed. Supports DPI principles and data sovereignty. So I'm not using the data. I'm actually Professor Inder has already spoke about data spaces. So indirectly, I'm pointing towards that here. The 5-year has been doing a massive effort into the data spaces for almost like 6 years now. So we have been involved in many data spaces projects. There is a reference framework which exists both for the greenfield and the brownfield. So the current platforms to evolve to a data space and creating the new data spaces. Next slide, please. Yeah, so data spaces with AI, the enabling the intelligent automation. So cross-sector, example, smart ports, digital twin for predictive logistics using 5-year. So this is one of the area we can do. Training AI foundation models on domain specific in real time. So this is the sovereign AI is a key for many of the countries right now to take the foundation models and train them with the sector and regional specific data to make it applicable to that context. The secure data exchange with the trust and usage control, and I think the trust is a key. It's not only about getting access, but who is accessing the data and how they're accessing it. I also add provenance and traceability is very important according to the data acts which are coming out across the world. Integration of AI, IoT edge, and 6G enabled ecosystem support for the credentials, where the trust can be built in one part of the trust framework. Next slide, please. So 5Air helps the European digital innovation hubs and open source community. Capacity building through sovereign tech development is scaling innovation. It's happened. It's aligned with the SDGs 9, 11, and 13. Local platforms plus global standard is sustainable at the scale. So this is something that which are key. The next slides, please. I would like to call for an action here. Just on this is that we invite every partners on the telecom, government, and industry to co-develop open interoperable infrastructure for a 6G era. So the assets are not owned by anyone, so it can be owned by the community. It can be used by the community and reused and with the local capacity building. The next slide, please. So why we matter here is that global demand for trusted digital public infrastructure is important. I think the governments and the authorities are opening up for opening up the data, provided there is enough trust in both sides, trusting the data which they are getting, and the data is trusted to be shared. Bringing ethical artificial intelligence into the game, compliance with EU Data Acts and SDG 11, vendor neutral digital transformation, so that the ownership remains through with the communities and the end users. Yeah, next slide. And I think I conclude this one from here.
Thank you, Chandra, for your time, and sorry about rushing it. And any question for Chandra, please post it on the Q&A. Let us have the next speaker profile, and we can. I invite Professor Raghu, Senior Scientist, Center for Data and Public Good from IISc. Professor Raghu is an alumnus of IIT Bombay, received his PhD from CMU, and his research interests encompasses many aspects like machine learning, computer vision, AI, and data mining. He has published over 180 papers in international journals and conferences. Welcome, Professor Raghu, and share your thoughts on role of data, a digital twin perspective.
Okay, thank you very much. And I hope you all can hear me and maybe see me a little bit.
Yeah, we can hear you, sir. Please go ahead.
Okay, so we've heard several speakers earlier today, and I think that's been a very good introduction to what I'm going to be talking about, especially the talk by Raja. I think he introduced the concept of digital twins, not just the concept of digital twins, but also modeling different aspects of the physical entity using different twins and how they come together, etc. So I'll be brief because we don't have a lot of time, but what I want to, so maybe you can move to the next slide. So what I want to talk about is the role of data and digital twin and why standardization is important, and also why a hierarchical modeling of data is important. So before I get to that, just a brief intro to digital twin. I think people use the word digital twin very loosely. In my opinion, they actually don't talk about digital twins, but they just talk about other things which really are not, they may not qualify as a digital twin. For example, at the lowest level, you could just create a dashboard for monitoring. So all you have is some kind of IoT situation where a lot of sensor data is coming in and you can just monitor the system. But that is really not a digital twin, but people still call some of these things as digital twins because somehow they seem to think it's representing reality. But the next level may be that you do some analytics on the signals that you're receiving, and then maybe create some alerts or other things which can be manually looked at by somebody, and then maybe they can do some intervention. But even this, in my opinion, doesn't really qualify. So the last two levels of intelligence, which are essential for a digital twin, may be thought of as actually necessary. So for example, if you're able to automate action through actuators, so you have a digital replica of a physical system, And if you make changes to the digital replica, the same changes should reflect in the physical environment. So that is when you could call it a true digital twin. So that is one aspect. The other aspect is that you need to be able to model the behavior of the physical environment, so physical entity. And this modeling can be about different aspects of the physical entity. So as we heard earlier, so you could have multiple digital twins modeling different behaviors or different aspects of the behavior of the physical entity. So now what does all this mean, and how is it related to data? So I'll come to that in a minute. So you can go to the next slide, please. So I think this slide probably is redundant. We've already heard most of these things, but I'll just spend a minute here. So the primary reason people are using digital twins is they want to use it for decision making and governance. And you're able to plan better because you can simulate what if scenarios and then and make informed decisions. So for example, there may be multiple options. For example, there are different types of things that you could do, and you could compare all of them using simulations on the digital twin, and then maybe it is also valid in the physical entity. And you can also use it for other things like predictive maintenance and effective emergency response and disaster response and so on, where you may not know what would happen. For example, if a disaster of a certain magnitude happens, because this happens very, very rarely. So because these are rare events, you will not have any data related to such rare events. So one way of doing that is to actually have a digital twin and then maybe simulate such simulation. But in manufacturing and construction, typically when they use digital twins, it's only at the design stage. So this is what is called a linear progression. So basically start with a design, and then when you complete the design, I mean in parallel, you can also use it to build the system, and there it ends. So you don't have to use the digital twin anymore, and that is the end of the cycle. You don't need to update the digital twin, so to speak. But in other situations where, for example, if you're using it in a smart city situation, this is very different because the city is a dynamic entity. It is not like a machine or something or a structure that you build and then it doesn't change after that. A city is constantly changing because there are new roads being built, new buildings are being built. There are so many other things that are being added to the city. Many things are happening in the city, etc. So you have to constantly look at all the building blocks of the digital twin, which are modeling the city, and you have to constantly update them. So this is like a cycle. So it's a continuous cycle. So you keep updating the digital twin, and then use the updated digital twin to do modeling. So what that means is that whatever data models that you are using, you need to be able to do this kind of update very easily. And if it's going to be very difficult, then it's not a very useful model as far as the digital twin is concerned. I think we can go to the next slide. We've already talked about so this is just a very a simple example of a digital twin of a city. I just wanted to flash this. The chart is kind of complex, but if you just focus on the yellow elements, so if you look at, for example, just the traffic and transport aspects of a city, at the bottom level, you may have a data exchange that Inder talked about. There's many different data sources. For example, you have traffic videos coming in, you have public transport information coming in, telco data that shows the movement of people, etc. So all this information is coming in. You have to transform it to some form that the digital twin can consume. But and then you can share that data, other people can use it. But what happens is that this data also can be used to build some foundational models. So for example, you could build a weather model, or you could also derive some data from this raw data, which may be more useful. So for example, if you can make predictions about traffic, so the predictions can be shared with other people who may use it for other purposes. So you can also have derived data here. And there could be many aspects of the city. So for example, you have a hydrological model, you may have a pollution model, etc. All these different models can interact with each other. And each one, you can think of it as representing one aspect of the city, right? So, and then using these foundation models, you may have some advanced models which combine the outputs from these foundational models in many different ways and produce some more sophisticated predictions or behavioral patterns. So that is, so all this can be again exchanged through another data exchange, which can be consumed by, for example, app developers or startups or other people. So, but one aspect that is different here is actually, if you look at the top left corner, of course, this shows how data is being is stored in many different ways because each entity may require a different type of modeling, etc. But when it comes to AI, because now everything wants to be, I mean, everyone wants to use AI. So we have to create a way to share all this data that can be used for training AI models. And so the training data has to be created out of all the data that we have shared in a form or in a format that is suitable for training AI models. So that is another aspect. And this model can be continuously trained as you get more and more data. It's not static. And those models actually can go into, they can flow into the foundational models that I talked about. So anyway, to summarize, I think we can go to the next slide. The last slide. So, if you talk about a digital twin, we are actually talking about modeling the behavior of a physical entity. It's not just monitoring, and there has to be a feedback loop. And but what we have to bear in mind when it comes to data is that the representations that we will use to build the digital twin, they may be at different levels of detail. So, for example, for micro simulations, you need representation at a different level. For meso simulations, you need representation at a different level, etc. So, whatever data model that you're picking, that should support different levels of representations. If that doesn't happen, then it is not very useful, because what happens is when you're combining different types of digital twins, they may not always represent behaviors at the same level. So if you want to make them interoperable, this requirement is essential. And the other two aspects is we have to worry about creating training data, right? So for different AI models. And also the representations need to be constantly updated. So when you're picking a data model or building a digital twin, you have to worry about how hard or how easy it is to update these models. So these are the main aspects. So basically the bottom line is standardization of data models is and format is very important. And it plays a very critical role in building digital twins. But also we have to keep in mind that we need to have representations at various levels and actually model the behavior rather than just do monitoring. So that's all I want to say here.
Thank you, Professor Raghu, for sharing your thoughts on the role of data in digital twin. Let's welcome the next speaker, the last speaker of the session. Yeah, Dr. Narendra is a retired master researcher at Ericsson Research. He is currently technologist at Art Park IISc. He is also adjunct faculty at the National Institute of Advanced Studies. With 32 years of R&D experience in Indian IT industry, his interests include software engineering, workflow management, web services, data management, analytics, and 5G and AML applications. Welcome, Dr. Narendra.
Thank you. Thank you. Hope you can hear me. So mine will be a brief presentation on the work that we started with Nokia Bell Labs on data architecture for 6G. This is joint work that we just started with Professor Bharadwaj Amrutor of IISc and one of my colleagues, Ratinamala at Art Park. Next slide. So my agenda is very short. Just two main things that I will be discussing. One is an overview of what we call sensing data architecture, and the other one is a concept of monetization of 6G data. The thing is that what we have been focusing on is that since these telecom networks generate huge amounts of data, and in the current 5G scenario, which is heavily message oriented, not data oriented, a lot of the data actually not being used properly. It's not being monetized, and one of that's probably, we believe, probably one of the main reasons that 5G has not really taken off as much as it could, especially the major use cases of 5G that demand distributedness. So we think that a data oriented view is important for 6G. And the data that is collected has to be processed so that it can be assetized and monetized. Next slide. Okay, so this one is our idea of sensing data architecture for 6G. Now, as I just now told you, current 5G standards do not consider data as a first-class citizen. So you have control plane, user plane, and management plane, but you actually don't have a data plane. Data handling of data and then applying AI algorithms on that data came as an afterthought, much after 5G came into focus. I mean, 5G started being implemented. We believe one of the primary reasons why 5G really hasn't taken off. A lot of the use cases hasn't taken off. For example, use cases such as URLLC, ultra reliable, low latency, MMTC, massive machine-to-machine communication, type communication, enhanced mobile broadband, a lot of the immersive communications, metaverse, and so on. You need to be able to, manage the data, process it, and do it as close to the point of origin as possible. Plus, you need to also integrate other sensors into the 6G network, including the non-3GPP sensors, the IoT sensors, cameras, and so on and so forth. So we have proposed a sensing data architecture, which we're still working on. We have submitted a report on this to the Bharat 6G Alliance. The idea is that it can integrate data from 3GPP and non-3GPP sources. It will permit the in-network processing of the data, which is right now currently really not there in 5G, because the data there is processed much after it is collected in a backend server. And hopefully it will usher in the promise of AI native 6G, which a lot of people have been talking about. So some of these key components here is the data exposure. Just as network exposure, you have data exposure. You have a charging. I'll come to the charging in the next slide when I discuss monetization. Security and privacy of the data, of course. Data processing, the actual processing of the data. What do you do on the data? What kind of processing? Like, for example, running AI algorithms. And if there's a streaming data, how do you process the streaming data? And so on. And an overall orchestration and management, OAM, as you can see, of the whole setup. The next slide. Yeah. So this is actually the crux of it, at least from my point of view. 6G is expected to be data oriented. There are proposals for having a separate data plane for 6G. And once that comes about, the immediate question will be asked is, how do you monetize the data? What are you going to do with that, all the data that is collected? So we need to have a data-driven business models. You need to have the notion of a data as a service. Now, data as a service has been around for quite a long time. And this is a diagram from a paper written some 12 or 13 years back. But you need to have a data monetization approach that incentivizes all the parties: your data generator, the data distributor, your third-party service providers, the one who wants to take the data and integrate the data and offer it as a service, and the consumer who eventually will pay for the data. So what we are looking at here is a proposed technical solution for monetization of this data. It will provide the following features: capture the data, interpret it, analyze, visualize, and should move from descriptive analytics through predictive analytics all the way to prescriptive analytics. And information as a service, data as a service, building on the collected data, and then using Gen AI to provide answers if needed. So essentially, the thing is modeling the entire 6G network as a kind of a data marketplace, defining data contracts for it, so that the data can be effectively monetized. And that will incentivize operators to adopt 6G faster, because then they'll realize that, okay, I'm going to make some real money out of this because the data I'm now be able to sell, because the operator is the one who controls the data anyway, right? So the operator it's in the operator's system that all the data accumulates, and it flows through and accumulates. So the idea is to monetize this data, and so for that you need to have a sensing data architecture for which you need to monetize. So this is basically the my proposal, the crux of our idea, and that's about it from my side. And was there any questions? Please go ahead and post them on the chat, and I will be happy to answer them.
Thank you, Dr. Narendra. So,
Sure.
any question for Dr. Narendra, please post it on the Q&A, and for other speakers also, we'll consolidate them. I think in the interest of time, let me try to conclude, give a concluding remarks. It's mostly my thanksgiving only, because now we have very less time in terms of the considering the next session that is upcoming. So I would like to thank all the speakers, expert speakers, who have shared their views on the importance of data, starting with Dr. Inder Gopal and Magesh and Nirit Rajaji and 5Air Foundation Chandra, and then role of digital twin, Professor Raghu and Narendra, all of them. So I really thank all the expert speakers, and my co-chair, fellow co-chair Nirant of Nokia, and Vijay Madan sir, convener of the session, and the session coordinator who has done a wonderful job, Chandrakanta, and all the delegates. I would like to thank everyone. And also, that's going to be a feedback form. Please share. I think it is going to be shared in the chat. The link will be shared there. And I again thank everyone for joining today. And thanks again to the expert speakers who have shared their views. Thank you very much. If anything, anybody wants to add from the speakers, Nirant or Vijay Madan sir?
Yeah, thank you, Pavantanji. I think thanks for everyone joining in the session. So please stay back for the next session on OFDM, which is going to start at 4:30. And thanks everyone for your patient listening. And we will get back with all the answers to the question as part of the session proceedings. Thanks a lot for posting your questions.
Yeah,
Thanks,
thank you
everyone.
very much.
Thank you. Thank you very much.
Yeah.
Thank you.